Guys, hope all of you are doing well. In this video, we're going to be taking a look at equivalent fractions, simplifying fractions, and comparing fractions. And I thought all of these had a lot in common. So I thought of doing all of them in one video. So let's get to it. And in this video, we're going to put into play what we learned in the last two videos. Factors, greatest common factors, multiples, lowest common multiples. So let's get to it. So I've already wrote some stuff down here. So equivalent means same value, but we're using different numbers. Equivalent fractions. Simplifying in same value, but we're trying to express the fraction as simple as possible, or with the lowest numbers possible. And in some cases, it's not possible because some of the numbers may not be able to factor out well. In those cases, we would leave them as it is. And in other cases, we would have to simplify it. Simplifying fractions, you're finding an equivalent fraction, as I said earlier, as simple as possible. And comparing fractions, you are going to use the same similar method. So let's get to the video. So rule of thumb: when you multiply or divide the numerator of a fraction, you do the same to the denominator. So if I have my fraction right here, if I multiply the numerator or even the denominator, it doesn't matter what order, I have to multiply the denominator by the same number. Whatever I do to the top, I have to do it to the bottom. And you'll also know that when you multiply the top and bottom by the same number, you also get an equivalent fraction. That's just one thing to know. So if on a test they ask you to find an equivalent fraction based on, so you get something like this, and they ask you to find an equivalent fraction, if you multiply the numerator and the denominator by the same number, then you will get an equivalent fraction. And that's the typical rule of fractions. And so what if I did this? So I multiply the top, I multiply this by 3 on a test or on an assignment. So I do 3, 2 times 3, 6. So would you say that half and this are equal? No, they're not equal, because we did not multiply top and bottom by the same number. So just keep that in mind. That's a rule of thumb for fractions. And that's also, so when you so this wouldn't be equivalent, and this wouldn't be accepted in fractions. So just keep that in mind. And also for simplifying fractions, actually let me first teach you how to simplify fractions, and then we'll see how it goes. So I'll just erase this. I hope you guys got all of this. So when we're simplifying fractions, we're using the idea of factors and greatest common factor. So let me give you guys a fraction, for example. So we have, let me give you an easy example. We have 2 over 6. This is your final answer. So on a test, your teacher would maybe say solve and simplify. Teacher would say solve and simplify. So your final answer would be something like this. But if you hand it in with this, you would probably lose marks, because your teacher clearly said here to simplify your answer. So when you simplify, the first step, look at factors for both numerator, for both num and denominator. So both top and bottom. So you have the fraction. So if you haven't already seen my fraction video, I'll leave it in the description below so you guys can see that, so you can understand this better. So first we got to look at factors for both the numerator and the denominator. So we'll start from the bottom and go up to the thing. And we also know that factors can't be greater than the number itself. So we got to stop with these two numbers. That's why I chose this one, so you guys understand it right now. So 0 factor, no, because 2 divided by 0 is undefined. So 0 is never a factor. 2 divided by 1. So I'm just going to put an arrow right here. So these are all the factors. So 1 works. 2 divided by 1, 2, no remainder, it works. 2 divided by 2 works. 2 divided by 2, 1 works. And we can't go greater than that, so it stops here. So 2 has 2 factors. Now we'll look at 6. 6 divided by 0 won't work, undefined, or it doesn't work. No, when you divide a number by 0, it's undefined. No, doesn't work. 6 divided by 1 works. 6 divided by 2 works. 6 divided by 3 works. 6 divided by 6 works. And that's it. Because remember, factors can be greater than the number itself. Otherwise, we would get a fraction. Fractions are not considered fractions are not considered. So factors can't be fractions. They have to be whole numbers, integers. So these are the positive factors for both 2 and 6. Because fractions, we're always dealing with positive values. So first we found the factors for both numerator and denominator. Tick the common ones. So now we're looking at the idea of common factors, greatest common factors, what I showed in the video. So tick the common factors. So what is common between here? So I already ticked this one. I just wanted to show you, but earlier, but okay, so which are common here? 1 is common, 2 is common, 3 and 6, although, so it stops at here. So the common ones are here. So we ticked our common ones. Now we find the GCF, which is the greatest common factor. So what is the greatest common factor between here? So it has to be common between the numerator and the denominator. So 2 and 6. Has to be common, and it also has to be the greatest in value. So we'll take a look here. 1 wouldn't be considered because there's another one. So 2, we have nothing greater than 2 because of 2 here. So 2 would be our GCF. Okay, see how we got there? That's how we get there. But we're not done yet. So now our fourth step. You remember how I said earlier there was a rule where what we did to the top we would have to do to the bottom? That rule comes here. So now we have to divide fraction top and bottom individually. Remember that? Top and bottom individually. Top and bottom individually by GCF. Or divide the fraction, meaning the numerator, by the GCF, then the bottom by the GCF, and you'll get a separate numerator and a denominator. So I'll show you how it works. So our GCF we figured out was 2. So this is our original fraction. It's the one that wasn't simplified. Divided. See how I did it individually? So what is our GCF? 2 divided by 2. 6 divided by 2. We put our fraction bar here. We divide the numerator separately, the denominator separately. Some people would do the opposite. They would just do this. If they knew division, how to divide fractions, they would do the entire thing divided by 2. But that's not how it works. Remember, it's simplifying. So 2 divided by 2, 1. 6 divided by 2, 3. So we realize that 2 over 6, when simplified, gives you 1/3. And also, when you simplify fractions, remember how when we multiplied the fraction by the same number for both the numerator and denominator, we got an equivalent fraction. Same thing here. Since we divided by an equivalent, by the same number, 2, the same greatest common factor. So 2 over 6 would equal 1/3. So this is equivalent fractions. You could figure it out like this. So if it's simplified, like let's just say it's 1/3. Let's just say they ask you to find an equivalent fraction for 1/3. You can't simplify it further. So you would have to use the multiples, or you have to multiply by the same number. Make sure you do it by the same number. It could be any number. unless it's a multiple choice question and they give you a set of things. But here you could choose any number. You can multiply by 3, 4, 5, 6, 7, even 20, 40, it's up to you. So 1 times 2, 2, 6. See, I multiplied by the same number. If it's simplified, the fraction is given to you and it's already in a simplified form, you can multiply it, the numerator and denominator, by the same number, and you will get an equivalent fraction. And if it's like this, you would have to do it backwards. You would divide by the same number. But when you're dividing fractions, you got to use the greatest common factor method. You can't just plug in any number, because if I did 2 divided by 4 and 6 divided by 4, it wouldn't work out. It wouldn't work out into a fraction properly. So that wouldn't be considered as an equivalent fraction. So make sure when you're simplifying fractions to find an equivalent one, you follow this greatest common factor method that I taught you here. And that was how you simplify factors. This is how we use the concept of greatest common factor to simplify it. I hope you understood it now. So right now we're gonna look at something called comparing fractions. Which is greater? Your teacher will give you 2 different fractions, and they ask you which is greater. And in that case, most of you would think that this is greater because it has a denominator of 25, and this has a base of 5, so this will automatically be greater. But in some cases, that's not always true. We have to figure it out. So this is where the idea of the least common multiple or the lowest common multiple comes into play. So we'll see how it works. So notice here, when you're comparing 2 fractions based on its value to see which is greater, does it equal, or which one is lower, you have to make sure that the base is the same. And this goes for, this is what leads us to our next video, which is addition operations, addition and subtraction with the fractions. So we'll see how it works. So we know that 16, 25, 1, and 5. So these are our 2 fractions. So we're going to do what we did for our factors. We write our denominator here. So we're comparing, in this case, we're trying to find the least or the lowest common multiple that would work for both 25 and 5. Remember, if you didn't watch my multiples video, please check it. It's also in the description below. So I'm going to write all the multiples of thing. 5, 10. I'm not going to write all of them because I'm pretty sure you would already know. I'm just going to write some of them. Okay, we'll stop here because I just want to illustrate because it keeps going on. So I'll just... So these are the multiples. See, all we have to do is just 5 times 1. And remember, 0 is always a multiple for any number, because any number times 0 is 0. So 0 is a multiple to all numbers. I just didn't list it here. So we got 5, 50. So we're going to stop here because I want to illustrate the idea. So here we have, so we listed not all, but some of the important multiples, or the ones that will help us to get this answer right here. So we listed all the multiples for both. So first, when you're finding the least common multiple, or when you're trying to compare or even add or subtract fractions with different bases, you would follow this method. So we listed all the multiples. So now, typically try, when you're doing a test, do your 12 times table. So go up to 12 times 5 in this list, and usually by the time you get to 25 times 12, you'll find your common multiples and your least common ones. So you don't have to go all the way there, but when you're first practicing, try to go up to your 5 times 12, or any number times 12. That 12 by 12 times table, try to use that. But usually when you're dealing with big numbers, you would find your common multiple quickly, because we're only looking at the least common multiple, and usually it's somewhere in the beginning, first 5, 6 numbers most of the time. Sometimes it should be in the beginning stage, in the set of numbers. So when you're dealing with big numbers, small numbers, it'll be somewhere in the middle. So I'll show you what I mean. So we have two common multiples here. We have our two fractions. So here we're not dealing with, remember in our greatest, when we were dividing, simplifying fractions, we used our numerator and denominator. Here we're just dealing with the bases or the denominator of the two fractions. So we got 5, we have 25, our two bases. So now we'll see which ones are common. So most of the time, you know that 25 is the highest, so we'll skip all these. 25 works. 25 is here. 50 is here. So 75, 100. 75 and 100 are also multiples of 5, if you know it, because it would go on, because 5 times 20 would give us this, and we go from there. But since we stopped at 50, we'll just consider these two are common. So here, now we're looking at the least or the lowest common multiple here. So our lowest common multiple, so if you might right away circle 50, because you might think of greatest common factor, but here we're just looking at 25. Because we're trying to compare fractions, we're trying to make it we're trying to find it in a simplified way quicker. Because if we use 50, we would then have to simplify it to the lowest common, to this denominator after. So it's recommended to use the lowest common multiple, but even if we use this, after you solve everything, you would have to simplify it again. So it's not a big deal, even if you miss it, but just always try to use a low LCM, because that's, it makes your life easier, I guess. So we have the common multiple, 16 times 25. So since in this case, 25 is our denominator, it's the same here, we would leave this. So 16 out of 25. Since our LCM, what we found and what is here is the same, we would leave it. So here, what do we do? So we have 5 and 25. So 5 times what will give me 25? Because we know that 25 is a multiple of 5. So 5 times what will give me things. So if you did a quick equation, 5x, so let x represent any number, any integer number, positive number, you would do it. So you know 5. So 5 times 5 gives us 25. Okay, let me erase this for you so you guys understand. So 5 times 5 gives you the number. So if you multiply the denominator by 5, you would get, when you multiply the denominator by 5, you would get 25. So remember in the earlier in this video I said what you do to the top, you have to do to the bottom. Same here. So what was up here? 1 times 5. So 1 times 5 is 5. So pretty simple because it's right here in the list. So 5. So which is greater now? So we made them both into the same base. So when you're comparing fractions, always make them the same base as possible. So it's same. It's by applying the least common multiple method, not the greatest common factor when you're comparing fractions or when you are adding or subtracting fractions in the next video. So greatest common factor is you will only use when you're simplifying fractions only. And simplifying fractions to get an equivalent and more simplified version of that fraction. So which is greater now? So we can just since the numerators are the same, which is greater, 5 or 16? Since the bases are same. 16. Because we all know that 5 is less than 16. Therefore, 16 out of 25, or 16 over 25 is greater than 5 over 25. So, but first we assumed that since 1 over 5, 16 over 25, this will be bigger. And it ended out being bigger. But sometimes this number that you had will be bigger. So we always have to make sure we use this method. So least common multiple method. So in this video, I've showed you how the greatest common factor, or the concept of factors, greatest common factor, multiple, and least common multiple come into play when we're doing certain topics in fractions. So that's why I taught it to you in the other videos. And if you haven't watched it, once again, I tell you it's in the description. So please check them out. So in the next video, we'll go on to operations with fractions. We'll first do addition, subtraction. Basically, we're doing something similar like this. And then after that, we'll move on to multiplying, dividing, which is a bit quite different from what we're seeing in this video. So thank you very much for taking the time to watch this video. I know it was a lot of stuff, and we will meet again in the next one. Thank you very much.